Let's talk about state-based development in database. And what does that really mean? Now, database code definitely exists in a state at any point in time, just like application code. I've got a version in my version control system, and it looks like a particular way. My create table has 7 columns in it, and my store procedure has a certain number of parameters and logic in it, just like my Java file would, just like my C# file would. But unlike application code, where you can completely remove and rebuild different parts of the application as needed, the database has to transition from one state to the next. We've looked at the SQL language. We've looked at how we actually perform development and the challenges there. But when I do that in development, I actually have to make decisions about how I'm going to provide those transitions. Now, certainly it's true of tables, but other objects as well. So I can't just compile some version of the code that's from version control on the database and expect it to work. I need to make sure that I'm providing the transitional code to the database when I deploy the changes. And that will something that will work correctly to move from one state to the next. In state-based development, we typically do this using some sort of comparison technology, where we'll examine the current state of the database, we'll examine the state of version control, and then we'll do a comparison and actually generate the SQL code that's required to transition from one state to the next. Now, we do this using various tools, various methods, various products that might help us there. But essentially, we're dynamically creating the SQL code in some way that's going to build that transitional code to move from the database that's in a certain version to the version we want it to be. Typically, what happens is we do this in development. We do a number of changes. We perform a comparison with our version control system. We store those changes. Then we take that version control system, we compare it to production or some other downstream environment. We generate a script that will transform the downstream environment so that it looks just like our development or what's in version control. We create this script and we deploy it. Now, what are the advantages of doing this? Well, the main one is that the developers don't have to worry about what changes they're making. Right? It frees up developers because they can make changes, undo them, make new changes, try different experiments. If they have to reset their environment, that's fine. They can just kind of freely develop code just like they would for any other application, just like they would in C#. When they think development is complete, just like they do, just like they might do in C#, they'll run that comparison, and then they'll determine what changes need to be sent to the downstream database. Right? This simplifies database development for the developer. They don't have to worry about tracking everything. The other advantage is that as we're making changes in development, and we're experimenting, which is one of our DevOps principles, if we discard something, if we decide that a change doesn't work, we never transfer that to a downstream environment. Right? Development involves making changes over time, sometimes significant time, right? Especially as I stack up all these changes. If I have to deploy all of those changes, including the ones that I don't really want, such as adding a column and dropping it, that can slow down my deployment, and that can disrupt my application. So I want to be very careful here. I've worked with some schema changes that take hours to complete on large tables. I know some people have changes that might take a day or more to actually complete on a large table. So we don't want to make those changes unless we absolutely have to and we're sure they're going to work in production. Undoing those actions is also very difficult, right? Today's world, we want to avoid downtime where possible, so we never want to send something to production that we don't need to. Now, this might mean that state change is always preferred, but that's not the case. There are definitely some downsides. The first thing is there's a domain of problems that aren't easily handled by state-based comparisons. For example, if we rename a table, I could change the name of a table from account status to account status lookup. It's more descriptive, it makes sense. It's the kind of change as a developer I might do when I'm refactoring something. It's problematic for databases though. I'm maintaining state, and depending on the process of tools we do this, we could get different results. If I were to run a comparison between a database that had the account status and account status lookup tables, how could I tell if I've renamed the table or if I've dropped the account status table and added the account status lookup table? It's very difficult to do. SSDT, SQL Compare from Redgate, some tools handle this, some don't. Certainly if two developers were to just look at the code, you wouldn't be able to tell that there was a rename. Instead, you might actually implement a drop and an add. We typically don't want to drop and add tables in production. That's a problem. There's a whole domain of problems like splits, merges, renames, things that cause issues in databases. So state-based comparisons typically don't handle those very well. The other types of changes is that I need to sometimes manipulate data as part of a change, and the state-based world doesn't handle data manipulation. For example, a not null column is a perfect issue there. I have to inject custom code, or I have to write some sort of pre or post script that will actually detect and deal with that sort of change and that sort of data manipulation. Upgrades of databases also are an issue. I have to go to discrete points in time when I'm working with state. I can't take a customer that's at version 2 and a customer that's at version 3 and give them the same script to upgrade to version 4. The customer at version 3 will have different sorts of objects, different states, and so I'd have to actually produce multiple scripts to upgrade different databases to a common version. That's certainly an issue. And the last thing is that I can't easily stop and start an upgrade at some discrete point in time. Typically, a state-based comparison results in an all or nothing deployment. Doesn't mean state is good or bad, doesn't mean that it's recommended or not recommended. There are just advantages and disadvantages of using state-based comparison. So you have to consider those in your particular environment. There are ways to mitigate these challenges. We'll certainly talk about how we can handle things like renames or not null columns. But for now, just understand that state-based comparison typically means bundling lots of changes at discrete points in time and deploying them.